So here in this problem, we are being provided with an equation of a parabola. So using this equation, we need to obtain its coordinates of the vertex and the focus. We need to obtain the equation of the axis and the directrix, and also the length of the latus rectum. Let us begin. So here what we'll do, we'll start with the given equation of the parabola. We have 4x squared minus 3x plus y equals to 0. So what we'll do, we'll keep the first two terms and then we're going to transpose the third term to the right hand side to get negative y. Now our goal will be to convert 4x squared minus 3x into a perfect square by using the method of completing the square. So here we'll first make the coefficient of x squared 1. So we're going to divide each terms by 4. We get x squared minus 3 over 4 times x equals to negative 1 over 4 times y. Now x squared minus, so the second term can be expressed as 2 times x times 3 over 8. So this number 3 over 8 is the hint that we need to add the square of the number, so 3 over 8 whole squared, but this is an extra term that we are adding, so we need to subtract it as well. So we have 3 over 8 whole squared subtracted. This will be equals to negative 1 over 4 times y. Now the first two terms that get converted into a perfect square, so we have x minus 3 over 8 whole squared. This will be equals to negative 1 over 4 times y. So what we'll do, we'll transpose negative 3 over 8 whole squared to the right hand side to get positive 9 over 64. So this will be x minus 3 over 8 whole squared equals to, we'll take negative 1 over 4 as the common factor. So we have y minus 9 over 16. So this is the equation of the parabola, although it is in the standard form, but the coordinates of the vertex has been shifted. To find out by what amount, what we'll do, we'll make two substitution here. We're going to consider x minus 3 over 8 to be equivalent to x in uppercase, and then we'll consider y minus 9 over 16 to be y in uppercase, such that equation number 1 now transforms into a new coordinate system as x squared equals to negative 1 over 4 times y. Now we can further express it as x squared equals to negative 4 multiplied to 1 over 16 times y. This is done so that when we compare it with the standard form of a parabola, that is x squared equals to negative 4ay, then we obtain the value of a. So here a will be equals to 1 over 16. We're going to use this value. Now what we have done initially, our parabola was given in the old coordinate system x comma y, and we have transformed it by using these two transformation equation into the new system with the coordinates x comma y. So what we'll do, we'll use this particular equation to graph the parabola, and with reference to this particular equation, we'll try to find out the coordinates of the vertex, the focus, and all the rest of the parameters for this particular parabola. So let us begin. So here we have the graph of the parabola x squared equals to negative 4ay, where a corresponds to 1 over 16. Now for this particular parabola, it's a downward facing parabola. Its vertex is going to be at the origin 0, 0. And then we have the coordinates of the focus at 0, negative a. Now the line which joins the vertex and the focus is referred to as the axis of symmetry of the parabola, and for this particular diagram, since the axis of symmetry is along the y-axis, its equation is given by x equals to 0. Now we're going to consider another point on the same axis of symmetry line with coordinates 0, a, and through this point a line is passed such that it is perpendicular to the axis of symmetry line. This line is referred to as the directrix line. Now the point is chosen in a very specific way such that its distance from the vertex, this distance is exactly equals to the distance of the focus from the vertex. And we have the latus rectum. The latus rectum is a straight line that passes through the focus of the parabola with its coordinates lying on the parabola, and it is perpendicular to the axis of symmetry line. Its length is obtained by taking the absolute value of 4 times a. Fine. Now in a case, we have a value equals to 1 over 16. So that means we have 4 multiplied to 1 over 16, or we can say that the length of the latus rectum is going to be 1/4 unit, 1 over 4 units. Okay. Now let's try to find out the coordinate of the vertex as well as the focus of the parabola with respect to the old system. We are working with the new coordinate system x comma y. So with respect to the new coordinate system, the vertex is at the origin 0 comma 0. This means that x value equals to 0 and y value that's equals to 0. However, we want to transform it back to the old coordinate system, that means represent in terms of x and y. So here all we have to do is use the same set of equation, x equals to 0 and y equals to 0, but instead of x we're going to use the transformed equation x minus 3 over 8, so this will be equals to 0. And then in place of y equals to 0, so in place of y we will be using y minus 9 over 16 equals to 0. So solving for x and y, that's going to give us the coordinates of the vertex of the parabola with respect to the old coordinate system. So that's going to be 3 over 8 comma 9 over 16. Then we have the focus of the parabola at 0 comma negative a. The a value that's 1 over 16. So our focus has having the coordinate 0 comma negative 1 over 16. This means that x corresponds to 0 and y is negative 1 over 16. But what we want to do, we want to go to the old coordinate system. So here we will consider x equals to 0, this equation, but replace the value of x with x minus 3 over 8 equals to 0. That's going to give us x equals to 3 over 8. And then we have y equals to negative 1 over 16, but in place of y, we're going to use y minus 9 over 16. And this will be equals to negative 1 over 16, which means that y will be equals to 8 over 16 when we transpose it to the right hand side, and 8 over 16 is simply 1 over 2. That means the coordinates of the focus is going to be at 3 over 8 comma 1 over 2. Okay, now we'll try to define the axis of the equation of the axis. The equation of the axis that's given by x equals to 0, but for our case we will have to transform it to the old equation. So we'll replace the value of x with x minus 3 over 8 equals to 0. So that's going to be the equation of the axis of the parabola. And then we have the equation of the directrix. The directrix that's given by y equals to a value is 1 over 16. So that means we have y minus 9 over 16 equals to 1 over 16. So that will be equals to y, implies y equals to 10 over 16, or we can say 5 over 8. So that's going to be the equation of the directrix of the parabola, and the length of the latus rectum that's going to stay fixed at 1 over 4, because the length of the latus rectum depends on the shape of the parabola. So it doesn't matter if we are calculating in the new coordinate system or the old coordinate system, the length remains fixed. So we have successfully obtained the coordinates of the vertex of the parabola, coordinates of the focus of the parabola, equation of the axis, equation of the directrix, as well as the length of the latus rectum.